Testing and testing, testing. Testing. Hello, Danielle. Yes. So we got 5 watching. Let's jump into this. So right now we have a release from, these are only tabs I'm going to work with right now. I released them from 44 pages. Well, it shows up as 44 pages on my format on this situation and on this structure. You know, grout was my number one thing about grout. It's only got 2 points of grout in here. Let's see if I can get this to work proper. It should. Okay. So when I look up grout, it says by using find. MCM showed concerns of the timeline between using grout versus gray concrete as per workability. And once again, FIG prefers the grout material, but it helps expedite the process. Otherwise, FIG will be okay. Now, let's just vindicate myself first real quickly. Look at this. CI to FIG. Do we need temporary shoring? FIG, this is the question. This is the meeting. We're looking at the meeting released by FDOT, guys. This is the link here. I'll give it to you in a moment. All right. FIG responded that it was not necessary. Remember I told you guys, he said it was, well, they're being nice on this wording because the report that I know of said that FIG said it would be give a false sense of security. So yes, FDOT is releasing this data here, but either the federal government is, of course, we know, terrible, and I mean, who would make a mistake of saying in that report that FIG said, Denny PATE said that it would give a false sense of security? Now, let me just see if that's in here real quickly. I have not read this document fully, only a few things, and wanted to get it going with you guys immediately. All right, so it's not said. So you know what I say to that? I say they're still, patting each other on the back. Because if you want to throw somebody under the bus, I guess that would also throw them under the bus, because if they said that, then, and they didn't do anything about it, it would look bad on them. So I guess they're protecting themselves by not putting that exact statement forward. But that, it's still the same end result. But I can't stand white lies. I just like the truth. All right. FIG responded that it was not necessary. Rather than carry load off that number/node, steel channels to 10/9 node. Guys, you know I can't wait to see some people come in here. I've been getting harassed by everybody telling me 11, 11, 11. Yeah, they talk about 11, but I kept, you know me, I kept preaching that these loads are going down 10. They're not going down 11 anymore. 11 is separating. It's not a load. It's not load bearing. It's a reversal, if it ever had intentions to carry weight. But here we are. The meeting was talking about 10/9. How awesome is that? For vindication on I've been waiting for some vindication. So far, getting it from FDOT. Wait a minute, let me find the plans for you. And I'll look at your comments and, back and forth. So bear with me. I'm going to scroll this. Bear your eyes. Bear with me on the eye movement. I want to get us the bridge. Okay. So number 11, 10 and 9, right here. What I've always said is the loads are transferring over here. And let's go to what I've always said, once I did my final, I'm still open to change. I can still change, but this was my final, as you guys know. I kept saying down 10, transferring over here, never making it. No compression on this. Of course, there's some, but insignificant. So let's go to back to 9 and 10. So 10/9 and post tension bars to capture some of the force which is better than vertical support. Vertical support would be so the temporary bracing, the shoring of it is what Fig is stating here, is that you do not. So I'll tell you what's going on here. He's stating, is it this one? Yeah, that don't put vertical support in here, but work on these guys here and possibly a brace here, but not vertical support between the canopy and the floor deck. Or he could be referring to underneath, which I doubt, because we clearly see that he states here, do we need temporary shoring? It is not necessary. Well, let's just use his word. That's their paraphrasing, that it was not necessary. And the true wording I told you guys was, it give a false sense of security. All right, rather than carry weight, carry load off that number/node, steel channels to 10 and 9 node, and post-tension bars to capture some of the force, which is better than vertical support. The diagonal member is what needs to be captured. They're paraphrasing here, obviously, and enough where you think you try to lose people reading this document. But it's cool they're releasing it, so we'll take it. The diagonal member is what needs to be captured. So the diagonal member is these guys. 10, 9, diagonal member, which needs to be captured. Or he could be referring to 11, but we're still talking about 9 and 10 in that image. So because it's ambiguous, I got to be ambiguous with you, even though he said 10 and 9. The diagonal member, not member, so, right? Fig mentioned that no repair should be done now. Interesting, right? But yet it appears he proceeded with repairs. Once backspan is there, and guys, look at this. Member 11 force will decrease, then repair can begin. Remember I told you the structure needs the backspan, and the backspan would tie it in with the post-tension cables across the roof canopy. Well, they finished. It looked like all of the base was finished on post-tensioning on this bridge right here. So let me come here for you. The base, where they come across all of them. And so this will now end my thoughts of it's no longer ambiguous for me by reason or deduction, extrapolation. We have 6 post-tension bars here, cables here, and 6 over here. They appear to all be filled in working order. They appear to be all capped, that they're all installed. So if he's still saying that the backspan needs to be connected, remember I wasn't sure. I've always had a theory that this entire structure over here could be supported by the post-tensioning of the cables here, longitudinal cables. But when they're saying that but also their video, if you remember, saying, look, they don't have the canopy tied in fully yet. That would have taken some of the load off of the deck here, because the canopy would have been supporting it. And that's what I've said about the design. If you guys remember in one of my videos, or a couple of times I hit on that subject. That's what they're talking about here when they state, once the backspan is that 100-foot, what they call the other span, the backspan. All right, so the other connection. Once the backspan is there, member 11 force will decrease, then repair can begin. Okay, so they're thinking number 11 force will decrease, the tension in it. Not going to mention compression yet. I don't think, when we got Google that in a minute right here, but that would tie the roof canopies together. So let's do this. Let's explain. Let me give you an explanation of that. Gosh, I'm sorry. I'm going to scroll to the top on you guys, so you're going to have to bear with me. It's going to be a few pages. And where's the mouse? Okay. So you can see the what they're referring to, because I don't want to lose anybody who's new to this whole thing. And let's scroll up. So this is the span that failed. This would be the back span. This ... is your post-tensioning cables going through the canopy. At least it's the rendering. It's the way I'm seeing the ... And if not, I'm seeing it now for you guys. And I think it's 4 of them that still would be installed, 2 on each side of these nodes, 2 on this side of the canopy and 2 in there. That would make this a long, more rigid, complex situation, along with this pylon going in. It would tie it all in, lock it all in, and this would lock it in, and that would act as one. So a lot of people hate on this structure. You know, of course, it's been a year and a half. I did a slenderness factor, just hating. I'm biased. I don't like post tensioning. I love what it can do. I just don't like it because it just seems destined to fail. And I wanted to load a video up for you guys using, it's for another guy. I was loading it up, but now I lost the video somewhere on all my hard drives, external drives. I was trying to find it tonight before this video, incidentally, to load it up to talk about what would fail first. If I were to think of your lug nuts on your car, and then you can put this anywhere you like, but if I were to tighten up lug nuts, let's call them 5 lug nuts. Let's say I torqued them all at 69 pounds or 70 pounds, make it easy for you guys. They're all exactly torqued at 70 pounds. But the clamp force is different. You guys are like, wait a minute, what's this mean, clamp force? Well, if one bolt threads are rusty, I'll get 79 pounds of torque before the one that's not rusty. So this might have a clamp force, even though I get to 79, let's call it 190. And then this one's got lubrication on the threads. Now I get a clamp force of 220. So follow this, 190, 220. That's all it really matters. I could do 2, but let's run around. 185, 165. Oh, here's 220. So what will fail first? Which one would fail first? They're all clamped. They're all holding your tire on, right? Quotations. They're holding your tire on. Which would fail first? What has experienced the most stress of all these? This one has 195. Let's call it again. I don't know my numbers in my brain. I just said, but say 195 up to 220. Which one would fail first? The 195? No, the 220 is the one that has the most stress on it. It is experiencing the most force. And that's the same thing with these longitudinal cables. There is a lot of, American Concrete Institute talks about post-tensioning, things like that. But there's some common sense that needs to take place too. And one of them is post-tensioning all the cables at one time. All at one time, so you don't create an imbalance in your decking. And yes, you're going to have all those pieces of equipment. And it's done all in one time. You get an equal force. You check them all the same. You release them same. You get all the data right then. You need more way to determine strain on this stuff, elongation. And so they have a factor that's. Let me move on from there. The factor can bite you in the ass. Obviously, it did in this structure. MCM show concern. Okay, where am I going here? Once the backspan, this is FIG speaking, 11 force will decrease, then repair can begin. FIG also stated that the prudent action is to share the load carried to 9 and 10 and construct a pylon diaphragm. So to share the load carried to 9 and 10. Guys, you know how much I've been crying about this 9 and 10. I am so vindicated now. This is FIG saying this near, so he realized it was going down 9 and 10. Which I've always screamed to you guys. There is no force in 11. 11 is not the issue. It's 9 and 10. It's 10. It's 10. It's 10. You guys know how much I cried that. So now I wonder if anybody's going to eat their words now, all these other groups that attack me. Hey, Embry. Now these other groups that attack me. You said there was an invisible bird. Thank you. Now all these groups that attack me for talking. Hey, I got to give myself a thumbs up so I can pat myself on the back. All right, look. So all the other groups attack me for not saying 11 is non-load bearing. Eat me. Embry must like that. Embry's my man. He's aggressive like that. So I'm laughing my arse off right now with this one. I'm smiling, actually. All right, the CEI represents FIU. The CEI to FIG question is here. Well, the mechanism to capture the load from the node, and we're talking node 9 and 10, has to be integrated into the pylon diaphragm, and will it remain in the structure? So they were talking about a steel, some type of brace, and that brace would carry the load from here to, of all things, the pylon, right? This is where I said, this is where the weakness, the issues are happening. So they 100%, Denny PATE And it took me, some time to see this. Denny PATE obviously saw, he had photographs. If I'd had the photographs, I'd like to say I would be fast too to come up with the answer. But it took me a while with the limited data I had to come to this. If you call, what, 4 months before I finally said it's going down 10, and nothing down here. Maybe 4 months. I finally said that with the data I was able to capture, or I finally committed to that. Well, maybe I committed earlier. What do I know? Maybe it was 4 weeks. CEI to FIG. Right. FIG answered that the temporary mechanism to capture the node preferably will not remain in the structure. So this 9 and 10 node to capture and capture it and redistribute it to the pier, the pylon. The pylon. So we come here, the pylon here. They're going to talk about shims. I did get that far before I jumped in here with you guys. Let me see, my man. Anybody saying anything first? You didn't say there are going to be tests. That's right. That's right, Danielle. Test. So now we go back to here. So let me get, okay. CEI to FIG. Well, the Met, right. This is the FIU's representative. And I want to shut down here real quick. Look at this. FIU will be questioning here. So FIU has a representative there besides the CEI. And if you guys know, just a couple of weeks ago, I gave you clarity on CEIs. I hope I did in a live video or something like that on my other channel. Clarity that the CEI had the same authority as FIU. When they speak, it was like FIU was speaking. And so FIU has their person here representing them also. They're both allowed to speak, obviously. CEI to FIG. Well, the Met, right. FIG answered the temp, right. MCM jumped in on this part, well, at least the way they put this forward. MCM showed concern of the timeline between using grout versus gray concrete as per workability. Now let's think about this. We talk about slander and stuff like that. This is FDOT putting this forward. FDOT putting this forward during a court case clearly is willing to stand by this statement. So I'm going to, we're probably looking at a real document, and FDOT is probably said with this document, FDOT is clearly saying to NTSB, hasta la vista, baby. We now covering our tracks. We're gonna start covering our ass. So this document here, clearly without NTSB's permission, would be a violation of their agreement. So now we're gonna start seeing things come out, I believe, the fight backs, but we will not see it come back from MCM. We will not see it come back from FIG, because you got to remember, any public statement they make could be a court action against them. So we won't see them speak up. If we do, that would just be ludicrous on their part. MCM showed a concern that the timeline between using grout versus gray concrete as per workability. Okay, do you see this? This is a jump, and I don't want to fall into post hoc stuff. I'm really about that post hoc stuff. Just because of one doesn't mean the other's tied together. So I feel like I'm being set up here. This is too much of a hand me for me. I kept saying the things aren't grouted. The grout, there's no grout. I don't like this. The way they're handing this to me right now, I don't know where this grout is specifically going. Is it in the tubes? Is it part of the shimming of the structure? They don't need shimming, and I saw only that far, the shimming part right here, and I got an image for you guys. It took friggin' 20 minutes to get this image. So this is the base. That's number 12, obviously. It sits on top of here, and these are like nylon shims. And they're going to talk about shimming under 12 right here. And I'm like, really? Because this is supposed to be accurate within, if you guys remember a video I did almost a year ago, it's supposed to be accurate within, what was it, crazy, 1/32 of an inch from here to here, and on the other pylon also. So what are we talking about shimming here? 1/32 of an inch? Wasn't it crazy like that? Like 1/8? It wasn't any quarter inches, baby. It was down there. And I was like, that's pretty damn tight tolerances. And these nylon things would make it happen. You just, come up with the level for each one. So why are they talking about shimming here? That would imply these nylons, I would say they're just perfectly tooled, if you will, machined, if you like. And under here, perhaps this wasn't perfectly tooled, and this is where it's not level. That's some extrapolation I'm gonna do based on the comments we're gonna read still. And I got to jump over here. Denny Pate here. Doss. What's up, Doss? Hi, Danny. Right. Back to, so let's read on. MCM showed concern of the time library using grout versus gray concrete as per workability. Okay, so there is this grout is mentioned, but it's down here. I think they address it more. Let's go back up here. Attendees: FIG, MCM, FDOT, FIU, 2 representatives, BPA, CEI, Joseph Morales. Okay, FIG's presentation summary. FIG pointed out the cracks look more significant in person than on photographs. You guys remember I said this? But remember, I only had access to that thing like it was a very short window I had access to it. And I said, I lost my damn notes on it. I said, somebody kept saying it looked worse. And isn't that amazing? It was Denny Pate that was saying it looks worse. It's more significant in person than on photographs. It was Denny Pate saying that all the time. Or FIG, if you will. Whereas I think I might have told you guys, so I need a correction, that it was somebody photographing in the field, giving it to the meeting live minutes. Well, remember, I'm looking at notes from, okay, I was looking at notes from, yeah, I think I might have said that already. Yeah, so I'll jump down that hole. From an OSHA report. So the OSHA report made this statement here. Temporary construction loading condition. Bridge was loaded onto the permanent support on 10-3. This is just like, documents, matter of statement or matter of, I don't want to say fact, matter of, yeah. Immediately after the move, CEI and FIG inspection showed nothing after distressing members 2 and 11. And you guys, I just did a video today on that, right? Isn't that ironic? That I said, look, this stuff looks good to go right now. And that was that day. I don't know if it's DOS asked, was it that day or somebody else did. That was that day, that video. I mean, the image I showed. On 3/13/18, MCM emailed FIG documentation regarding the cracks. Right. So MCM emailed FIG regarding the cracks. So that was on 3/13. And FIG instructed MCM to install the recommended temporary shims in the pylon base directly below members number 12, nodal area of members 11 and 12, between the permanent support shims. So this is weird, between the permanent support shims. So this is what they're talking about. This sits here. Under 12 is lined up, center line there. I can't magnify anymore. But between it. So right about here, there's some type of shimming issue they want to deal with. I really don't see, this didn't crack out here. So this is just sort of, yeah, it should have been done. It also should have been anchored down all the way through up to here and strapped down. So I don't see that as failing anyway. So it's kind of a smoke and mirrors, non-starter, and just a matter of conversation that took place during this meeting, as far as I'm concerned, that this is nothing. All right. It didn't crack inside the diaphragm area there going straight down. At least we see no photographs of that. FIG assured that there was no concern with safety of the span suspended over the road. Okay, we already heard that one. The importance of the pylon diaphragm, pour, and back span construction was discussed. Okay, a temporary mechanism to capture the nodal zone and the time frame to deliver the plan was discussed. So this was talking about the repair. Nodal zone would be that 9 and 10, 10 and 9. However, they wrote it twice, 2 different directions, I think. Refer to attached analysis presentation photographs. First few slides were not photographed. Whatever that means. Okay. And here it is. See, I said 10, 9, 9, 10. They reverse it up. See, steel channels to 10, 9, nodals. And isn't that amazing? This concrete, beautiful bridge, now is going to get some steel channels put on it. And what are the intent of the steel channels? Now I'm doing my extrapolation, but remember I'm biased because I'm biased. I'm all about this 9 and 10. So, this is the way I see that steel channel going from here, maybe from here all the way down to here and tying in here, steelworks. I can't imagine it just being here and going over. I can imagine going Let me think of it like a can. Well, I can imagine it going the full distance from here to here, that distance to wherever it stops here. And then you want it to look pretty, and you probably run steel down the whole damn thing decoratively. And then you play it off with some railing, call it a railing detail, and you're going to tie in the railing to the steel member for whatever reason, and representing to the steel people of America, because you realize you're using concrete, you want to give an homage to steel. That's the way you play that shit off. All right. Fig answered that the temporary mechanism to capture the whole node preferably will not remain in the structure. And I guess there goes my railing thing about the homage, but the homage might have came about. MCM to Fig will be the temporary. Right? Will the temporary shims remain in the structure? Now, the shimming they're talking about under 12 and oh, hold on. It's dealing with the cracks. Okay, I am acting. I think I know what's going on. Let me back it up. I think I know what I'm looking at now. Where's that 12? On the 12 again. You guys can probably see it. I'm bouncing around. That 12, 11, 12. The shims in the pylon base directly below member 12. Between the permanent support shims. I think that's some weird wording, but I think that the intent might really be that this is the pier. Oh, okay. So I need another image. So the pier is it might actually be, now that's right on the edge of it. I was thinking right here, the bracing that they're trying to sneak in there. Let's go down. Let's keep rolling with this real quickly. All right. This is MCM to Fig. Will the temporary shims remain in the structure? MCM's asking, structurally, will they remain in the structure? It's a good question. Fig replied that the temporary shims shall be removed. However, if it cannot be removed, we will work something out, make it decorative. All right. FIU to CEI. So FIU in the same meeting is dressing their own expert, if you will, and they asked, what is the CEI opinion on presentation analysis from Fig? FDOT responds to Fig. Wait a minute. FDOT to Fig. Oh, I'm sorry. They don't answer it. They're down here. But FDOT to Fig. FDOT requests a copy of Fig's analysis presentation to give their structural group. Okay. FDOT to Fig. They want Fig's analysis so they can present it to their structural group to look at it. CI at that point, we cannot comment. We'll follow up on the request and expedite in 2 to 3 days with Jack Perez and Louis M. Vargas. So I forget who they are. They could be the CI engineers, other further engineers, or it could be anybody. It doesn't really matter. They punt it. They bunt, whatever you call it, punt. They didn't receive this question. They just punted. Fig comments that analysis predicts diagonal cracking. So we know it's diagonal cracking. We see the diagonal cracking going up the member. CEI to Fig. Now, CEI, that's the FIU's representative, remember? To Fig, request clarification on amount of transfer post-tension assumed for the nodal shear stability analysis. Okay, request a clarification on amount of transfer post-tension assumed for the nodal shear stability analysis. He wants what he said here. He's going to, they want the data. Fig clamping action and Fig clamping action only on transverse strands. So they're leaving out they have a lot more details. Maybe it's in the photograph down here, but but maybe the transverse comes across, right? Longitudinal, these guys, transverse are the ones that come across this deck. So maybe they're when they go to put this brace on, he's saying that the only strain is going to, the stress is going to be on those. I'm extrapolating at this point. FIU commented to FIG that nothing predicted this cracking. FIU, you made a comment. FIG mentioned that the post-tension bars in their permanent condition have less stress than under construction conditions. It's like a nothing statement there. It's like smoke and mirrors. That this just stands out by itself. It's nothing to really talk about here on these two. They're two comments that don't tie in really. CEI to FIG. Are there any restrictions of any load on that side? That side. Not that end. He's saying that side. FIG answer, but remember, this guy speaks Spanish or whatever he speaks, and he writes weird. If you guys saw, his grammar's terrible. So side could be the same thing as end to this guy. I can't assume that he means the side we see the cracking on. FIG answers that until further restraining of the node, no load other than necessary is needed. Also, member 11 is going to be tension today, 3:15:18. So he already made this during this meeting. He's saying we'll be tension. He's already processed that it will be tensioned. Okay, so if it's already in compression, you don't need to tension it. So there you go. It's not in compression, but he's going to add a little tension to it. CI to FIG /MCM. CI to FIG and MCM. Will there be a crack monitoring plan? CI had been monitoring the cracks and insisted that FIG MCM perform the crack monitoring as well. FIG MCM had no response. MCM to CEI. Have the cracks increased in length or depth? CEI confirmed cracks have increased in length daily. FDOT to FIG. Are you going to continue to figure out why it happened? FIG responded that all we know, FIG responded that all we quote, know is that it just happened, end quote. All right. Awesome. So leaving out a lot of the rest of the statement, no is it just happened. That's a weird piece of quote they snatched out of there, isn't it? That's unfair to FIG for sure. MCM to FIG. Will there be further inspection inside the cracks? I like this. So MCM, the builders, asking FIG, the engineer, will there be further inspection inside the cracks? FIG answers that they don't want to core concrete out. They want to move forward and seal cracks before being covered. Whoa, he says you have a plan. And they want to seal seal cracks before being covered. What the hell? FIG insisted that right now to not do any repairing of cracks until stabilizing the node and pylon diaphragm. The rest of the corrective actions will be after construction of backspan. So yeah, he punted. He thinks the backspan is gonna give it reinforcement at this point with the longitudinal cables across the canopy. That's along with the everything being tied in there. Number 12 being tied in. FIU to FIG. That's what I extrapolate. FIU to FIG. This concrete is sticky, flowable because of the titanium dioxide. This is FIU to FIG. FIU stepped in now, not the CEI, but FIU. FIU is concerned to be used under the pylon diaphragm. Okay. It's sticky, flowable. That's kind of opposite, isn't it? It's sticky, flowable. How is it sticky, same as flowable? That one's got me weird. Let's look at FIU now because I can research these people now. FIU's people is John Cal and Patrick, whatever, Meager. Sticky. Where are we going? All right. Under the pylon. So that doesn't have anything to do with anything. I would want to know is it, this PSI. The bridge is 4,500 PSI. What's your crowd of your PSI? This has to be 4,500 also. You don't change your grout. You don't make your grout tougher. You don't make it, you sure enough don't make it lighter. So it's 4,500. That's where that stays. So I don't know about all this weird talk going on from engineers instead of going, hey, we're just keeping it at 4,500 is what they should be saying. The bridge is 4,500. Our grout's got to be 4,500. So I don't get it per FDOT's requirements. I'm giving that to you guys from FDOT's requirements. Scary. Yep. All right. So we go back to FIG. This is FIG talk. Reassured that means that methods will be considered when used in pour. Okay, so this is a not placement. So this is a serious piece of concrete they're talking about adding. You know, this is if a pour, you're not, you know, if it's grouting, it's just a little bit of tooling going on, but we're in some serious grouting. I mean, if it's shimming rather, we're way beyond shimming, whatever they're referring to right here. You know, so this still needs some explanation to me when I see this word here. FIU to FIG. So again, it's the FIU, not CEI. Why is the bridge less than 950 tons versus Barnhart's weight? Why is the bridge less than 950 tons versus Barnhart's weight? FIG and CEI confirm that it was built as per plans and an approximate weight of 950 tons includes an increase factor. Why is the bridge less than 950 tons? So apparently the bridge is less than 950 tons, but they include, so the 950 tons included an increase factor. So it actually weighs less. Okay, moving on. MCM and Barnhart uses the different weights. So their own FIU representative is an idiot. If he didn't know that Barnhart is questioning it now at this time of the late in the game, instead of right then when the Barnhart comes forward and says, hey, we calculated the load of the structure at 910 tons. And now he's bringing it up. So he's trying to, you know, blame the weight. Guys, you can't blame the weight on this. Everybody wants to blame the weight. It's bridges weigh a lot of friggin' weight, all right? So get over that. Boats weigh a lot of weight. Ships do. MCM the FIG. Power lines. You guys, a lot of you electrical engineers. Power lines weigh a lot of weight, right? MCM the FIG. What is the time frame for temporary mechanism to capture nodal zone? See, I love this. MCM the FIG. So now we're talking about my nodal zone. You know we're talking about my 910 up here. So MCM the FIG. What is the time frame to temporary mechanism to capture nodal zone? FIG. Saturday. So he said he was going to go back and work on this, but he's already set up the Saturday to make this nodal zone repair. CI to FIG. Are you saying for the post-tension procedure? CI to FIG. FIG needs clarity on this. FIG replied that they will not be staying. FIG was going back right after the presentation because they had work to do on this. Oh, are you staying? Meaning, are you? I'm using a staying as stop. You know, staying as in, hey, we're going to put a stay on that right now as a stop. He means literally staying as in, are you staying to observe the post-tensioning procedure? And FIG replied that they will not be staying for the procedure. So let's go back up here again. I'm looking for the FIG. Denny, PATE, Eddie Leon, Dwight Dempsey on the phone. Ah, that's that phone call, guys, I told you about. Someone was on the phone with Dwight Dempsey. Ah, he was getting the data too. Okay. There we go. Okay, FIG was going back right after this presentation because they had to work on this. CI to FIG. Requesting a copy of the PowerPoint presentation. FIG MCM will provide. Right. CI to FIG. FIG, and so this will be the reply. FIG MCM will provide. So FIG is referring to himself as FIG/MCM. And remember, the insurance companies were saying that FIG is acting as a builder, and that's not what they insure them for. They insure them as an engineer. And they were saying, you're acting like a builder. So this would kind of get you in trouble. But CEI to FIG. Has it been peer reviewed? CEI requests that it wanted more eyes on this, and that the more eyes on this, the better. FIG concurred. CEI to FIG/MCM. Provide to CEI the stressing procedures that will be performed on 3/15/18. MCM responded that we provide. All right, guys, let me jump forward because I haven't read this. Remember, I said that report said that Denny PATE said, put it back to where it was when it was sitting over there in the impound. Now, let's see if they get that. I call it the impound, when it was on the side of the road. MCM responded that we provide to CEI. MCM clarified that VSL was currently on site to perform the stressing operation with the corresponding stressing procedure. Which we now know, or at one point we know it was number 2 and then go down to number 11. They were obviously working on number 11 during this meeting. The collapse was 2 hours later, and I extrapolate that because when we watched them post tension the rods before, they took 2 days to do it. And now only 2 hours into the day of this meeting, they're already down to number 11, and they reportedly already said they tensioned number 2 already. So days before when they first started doing this, and I did a video on that, they took 2 days to do number 2 and number 11. And now, the day of this, they dust off number 2 in a heartbeat. They're already on number 11. So that's my extrapolation. All right. FIG requested to MCM the compressor strength test results. Requested to MCM. MCM stated that the laboratory results on concrete had exceeded the design compression strength of the 4,500 PSI. So he's questioning. FIG is questioning the. Well, that's telling too. It's this late in the game, and FIG is now asking for compression results of concrete. So we can extrapolate that the chief engineer, the head engineer, doesn't even know is not even keeping track of this baby, whether the concrete passed or not. That he's just basically off in la la land, I guess, because that's just craziness there. FIG requested the MCM the compressor test results. MCM stated that the laboratory results on concrete had exceeded the design compressor strength. And CEI to MCM. When do you have in your schedule the completion of the construction of the pylon diaphragm and backspan? Are you planning on rushing the completion of the construction of them? MCM responded they are following the schedule, but they will expedite the construction of them. That's a good answer. Don't ever say you're going to rush. FIU requested the progress meeting to be moved to 3/19/18. So he said he'll have the plan on Saturday. That was the whatever. I forgot when this fell. You guys can give me the day. What date would that have been Saturday? Do you guys know? Oh, we got some photographs, and here is the presentation. You can't beat this. Temporary construction condition. Both the exposure of the diaphragm to this Denny PATE's presentation, apparently, and missing a couple of photographs as they stated. Both the exposure of the diaphragm and the maximum load on the shims at this location are temporary. So this is where they talk about they're temporary. What if I can't get them out? And he says we'll discuss it later. The end of the type 2 diaphragm becomes protected and encapsulated by the pylon, and CIP backspan concrete is placed. They're going to tie all this together. Captured, as they said. And we'll go here. The bending moment that developed in the continuous structure when the false work up, there we go, backspan is removed, will reduce the load on the shims from the current values. Okay. So the false works, I talked about that with you guys. And let's move on. Temporary construction condition. Awesome. I can zoom in. That's the backspan. Let's see it. Okay, so I had to do a correction. I said 4,500 psi. You know what? I'm missing it. I'm missing it's 6,000. I apologize. I'm thinking out of a bridge I'm messing with. It's 4,500. I totally stand corrected. I apologize. It is 6,000 for the structure. Stress post tensioning of the backspan in the following sequence. Stress deck long. You guys, you know how much I've been crying over this. I've been putting this forward in a lot of my videos. And there it is. But now he's calling this temporary construction. Erect temporary beam in false work. Okay, that's the river. That's the false work. Oh, this was going to be built in place. This says temporary construction condition, but just so you guys know, the plan did say this will be built in place. So even though you see this and that was part of the plans, the original 2017 stamp plans. So I'm trying to see what's different. I can't quite make it out. Intermediate section. I really don't see the a deviation from the plans here. Now, I don't see a deviation from the plans. And if this was going to, concrete takes 28 days to cure. So we were talking a month here. So they would put a temporary brace up here, and it's going to stay there at least a month. I mean, this takes, another 2 months to build. So we're talking, this would have been 3 months before they'd have been working on a pylon probably, or maybe they could start loading this area already based on whatever the pylon's structure is, right? The loads and whatever they decide. Oh, there's our shimming. There we go. Immediate action, Tuesday morning. Upon seeing MCM's information, FIG requests that, as prudent action, MCM immediately install temporary shims directly below the nodal area of members 11 and 12 and the top of the pylon pier. While further evaluation were going on. I told you guys this had to be shimmed anyway. This was supposed to be grouted, actually. Shim, they're calling it. The plans say this was supposed to be grouted. That this place is on here, this is grouted, this is secured. And it just feels, remember, it's on that nylon right now. And this is a good image because the cracking is in here somewhere. And I didn't find any cracking in this part of the bridge base, if you will, the pure cap. I can't even call it a pure cap. It's all one. So, but you get it. Okay, the shims placed during the span move. Oh, they're good. Here's the nylon. Unless shim plates, typical 3 foot. We're talking 6 inches here. And they're saying that span here is, well, what's that, 3 feet? 3 feet, 2 inches. That's a big ass span. I can't see it, but is that, I thought that had nylon there already. I could have sworn I saw nylon. This is wrapped in nylon. So the grouting would be more on the backside of it because this gapping, well, it identifies as 6 inches. What we got here? Danielle show. Nodal zone. Yeah, nodal zone. I'm 6 inches. Yeah, thank you. I am kind of following. Seems like they knew the bridge was this word there. I can't say Google sanctioned me. So 6 inches, right? Yeah. Nodal zone. Embry, I hope you caught that 10 and 9 stuff that I was talking about. So let's go back to, where is it? Oh, we got 2 more of this stuff, exhibits, but I didn't open them up. I had to get you guys involved. So 6 inch. So this is where they said this needs to be grouted, but what's up with that? I don't see the bars in his detail coming up here. And the videos I've watched, it had nylon going all across here. So this, Denny PATE doesn't even know what PSI concrete it is. So he probably thinks this is real, that it's a gap there. When there is no full gap like that. Well, I could be wrong, but I don't think I'm wrong. Well, I'm doubting myself because they're spending so much focus on this. Let's look at it. Temporary shim region is shown below in blue, but there's no cracking in that member. Wait a minute, is that a current image on its base? MCM. This is when it's installed, right? This is at the installed location. This is at the installed location with this MCM sticker, right? Or was that on the other side? Huh. My point is, we were seeing no cracks. But wait a minute, then we would have seen cracks here. So I don't know, maybe it's an old image. Moving on. What's this temporary stuff? It was supposed to be grouted. The plans call for grouting immediately. So Denny PATE doesn't follow his own plans. What's going on here? I'm feeling real weirded out by this guy. You know, you're sending me some crazy signals. I read all your crap and you can't even remember that this is just supposed to be grouted, period. Grouted, period. There's no temporary and all that other junk you're talking about here. It's supposed to be grouted. But no crack showed up on the outside there. So kind of academic. The spans, the unsupported spans are like 6 inches, right? So the other one's 1'3", and the post tensioning is on the outside of this thing anyway. And we know that they don't have it going down the middle with longitudinal post tension cable. So yeah, so what, you put a little grout there? It's all 6 of one, and half a dozen another with this bridge, because there's no besides the transverse cables transferring the load to the longitudinal cables. There's nothing down the middle besides a pipe. Tuesday morning, after about an hour review and evaluation, FIGA conducted sufficient supplemental independent computations to conclude that there is not any concern with safety of the span suspended over the road. MCM was so notified by Dwight Dempsey. Dwight Dempsey is what is he, in Pittsburgh, Pennsylvania? Really? Or something like that? The method and results of the independent evaluation will be discussed in some detail further below. Yeah, I can't wait to hear this independent stuff. How can he be independent? Yeah, it's kind of weird. Yeah, that's in the impound. Historic history of the specific operation. The span was fully self-supporting on the end diaphragms and the casting area, full post tension, etc., for several weeks prior to the move. Remember, I did a video on that, guys. I said, look, this thing's been load tested by its own dead weight. You guys remember a video I did on that? And I said, it's load tested, dead weight. And here's Denny PATE saying that. So I feel real great about that video now, too. That I said, hey, this thing's been load tested, dead weight load tested. There's the false sense of security back in August. That's me saying no sharing possible on 11 August. It's more than 2 pages, you can bet that, but I want to find this. Give me a moment, bear with me. Some of these are marked private after doing long ass. It's my favorite video here, one of these two with this wood, with that green thing. Right here. Dead loads will be cause of, no. Here's number 10 again, number 10. I'm all about number 10 way back in June, right? Okay. There's the form work removal was my false work removal issue I had. That's not true anymore. Negligence deviated from supporting during transportation. Well, that's not true. What is true about this is that the SMPT mover, per FDOT's recommendations, it's not a shell, says that the builder should have consulted with them so they can tell them how to engineer the bridge for their supports. And there's the grouting issue. It looks like this, I think, the thumbnail. The thumbnail. Looking for the dead load one, if you guys remember it. Right here. FIU bridge collapse and load testing using equal unsupported span as final installation. I did a video on that back in May 1st. And that's the video I did on that. And 9 people hate me. Anyway, where I talk about in load testing using equal unsupported span. And this is what Denny PATE states in his presentation, is that looking at it, grout is it's typical, you grout something to it transfers the load equal. It's got to make sure it doesn't crack out, right? During the time the pylon and diaphragm was uniformly supported over its entire surface area on the original soffit during casting. No significant cracks or de-stress of this region were noted. Well, we saw a lot of cracks, but they call it no significant. Denny PATE does in his presentation. And right here, the span was fully self-supporting on the end diaphragm in the casting area. They call it the casting area for several weeks prior to the removal. That's the load testing. They could have put a water bladder up there and really load tested this, but they didn't. Water bladder, to do the loads. Similar support condition. The span of the road is supported at similar locations as were used in the casting area. So yeah, the distance. The difference between that permanent bearing at the EJ south end and the difference being that the permanent bearings at the EJ, which is, where is it here? South end, and the 4 shims rather than a uniform contact pressure at the pylon north end. Well, that's interesting. They're saying that they have the 4 shims rather than uniform contact pressure at the pylon's north end. Well, that's not true either. Guys, I'm nuts over this damn thing. Both ends of these have nylon on it. On the other end, the guys were standing there. The crew was standing there, the 2 guys, for some time. I saw the nylon. That had nylon on it too. Well, nylon type materials. It could be nylon. De-stressing of temporary post-tension bars. Okay. Now this is interesting because this is his presentation. The only other notable difference from the condition in the casting yard location is that the temporary post-tension bars in numbers 2 and 11 needed for the move were de-stressed. That ends that. The number 2 and 11 was only for the move. I get credit for that too, because I said it was just to take the loads off. I'm not going to bore you guys with that, but it was over here just acting for shear walls, just to keep it from falling off. The 2 and 11. So, yep, got that one covered too. Figured out that intent was real too. Okay, a study of the local effects of this detensioning has been made and will also be discussed later in the presentation. So what effect would it have? And we'll see what they say of detensioning it. If any. Okay, design recheck. Let's go back to that one more time. The only notable difference from the condition in the casting yard locations is that the temporary post-tension bars and diagonals 2 and 11 needed for the move were de-stressed. They said for the move. Denny PATE's own plan say it will not be de-stressed until the total completion of his span. So I have a real issue with following his own directions, or who did not follow his directions. His directions were pretty clear to me that post-tensioning in 211 would not be detension until the main span was complete. The main span cannot be complete until the back span is complete. The back span is tied into the whole structure. In other words, you can't detension, and that's why I made a video saying, hey, how were you going to detension this if you follow this technical statement of his saying 2 and 11 will not be detentioned until the main structure is complete. And I'm going to show you that just now in his 2017 stamp plan. Oh, you son of a... I'm still in 2016. I'm going to show you that, and okay. 2016 still? I'm going to give it a fast brush. Well, I guess not. It's a little delay here. Oh, that's right, because I'm live. This is live online, so it gives a little delay. So let's get down to that 2 and 11. It's going to be on the left-hand side, so I got a nice rough idea where it is. Over here, you see this 2017 stamp plan, so we're solid on that. There's your 6,000 PSI. Post-tension bars and members right here, number 8, please. Post-tension bars in members 2 and 11 will not be grouted and will be de-stressed after main span construction is complete. Do not remove after main. So this was a wrong step. The question is, was it approved? I never found anything in all my disclosure stuff, guys. So this was not to be detentioned. So, therein lies, Denny PATE, this thing might have worked. It might have worked, but they deviated from his own plans. The cracks, though, I don't like the idea of cracks in it, but this might have worked, and also probably has some post-tension failure in the longitudinal cables. So that probably needed better monitoring and better workout. Design rechecks. Flexure stresses on the bottom of the transverse diaphragm beam. So this is what they're calling the diaphragm. Well, he's not quite identifying it as such, but this is what I'm extrapolating. This is the diaphragm transverse beam going across this way. This is the part that sits on the pier. Here are the shims. Again, no shim appears present in this drawing. The field operations were conducted with the intent of achieving reasonable equal loads at the 4 shim locations. Reasonable equal loads. Well, that's not... Let's read that again. The field operation was conducted with the intent of achieving, reasonable equal loads at the 4 shim. I think it's very reasonable to say it's got to be within 1/16 or 1/8 of an inch. They've got engineers there. They've got surveyors there. They can make this in this little bit of distance. You can clearly nail 1/16 of an inch. Assuming that, and the bottom of this too, you can plane that to get it within 1/16. That would be pretty difficult, actually. If you don't have a bottom, if you don't make this perfectly bottom flat in your formwork. Assuming that, because you can't, while it was temporarily up in the air on those jacks, the transporter, you could have then planed it flat then, but that would look like a mess, right? People would get freaked out on that. Assuming that was achieved, and that the span weighs 950 tons. Barnhart told us that it was somewhat less. We are trying to get the as weight value. And the following load diagram was developed. So Barnhart told him it was something less. But I thought they said a moment ago up in the conversation that they did an overcalculation of weight just to, margin of fluff. But now his presentation says otherwise. Is that Barnhart gave him a different reading. I don't like where he's going with that, but let's move on. Flexural moment and flexural stress. Bending moment. Plus or minus. Plus or minus what? You usually give a plus or minus of something. I love that. This is how you talk when you're like, you know what, I need an out. Denny PATE did this. At this point, I know that these are just fluff statements, fluff stuff. This is when you don't do plus and minus and tell what it plus and minus what plus and minus what 1 kip, 30 kips, what beam cross section 4 foot tall by 2 foot wide. So this beam, let's go back to it. This guy. Diaphragm beam, 4 foot by 2 foot. And since it's mentioned the beam here, I'm guessing this is the bending moment of that beam, what it can take. So now you guys can do the load calculations and all that. This is awesome because here's his answer. Beam cross section 4 foot by 2 foot wide. Bending section modulus 5.3 foot squared. Bending stress same as here. Took a screenshot of that. Oh, I have a little fun with that another time. All right, moving on. Oh, strut and tie. Design strength check. Oh, can't get it. Given the dimension of this region, the most appropriate design approach is the strut and tie method. So I had a couple of people tell me that number between, and I said your guys are all full of it, that a couple of guys tell me they're engineers, and that you guys saw that one video I did, and that this is you don't know what you're talking about. This is the load bearing. This is a non-force member. This is non-load bearing. Well, we're looking at this member right here, guys, and we're looking at this. And I told them all that they're full of shit, and you saw my video on it. No matter what they say, this is load bearing. And here we go. One more time, I get supported in my statement right here. It's got 950 kips on the boy right here. Somehow it translates to 475 kips once you do what? 475 and 475. It has to be equilibrium, right? Why don't they put it over here too? I can't read this. But you see that? That's thousands of pounds. So it's no lightweight. That's, that's a lot of weight. That's tens of thousands of pounds. So there you go for anybody watching who kept telling me that, trying to tell me that I don't know what I'm talking about. Now you crackheads can bite me more. Bite me. Ember's going to sleep. Oh, Danny's going to sleep. Good night. Thank you. Good night, Danielle. So more bite me medicine for you guys that come in here and try and troll me if you're here, if you look at this video later. Aha, I'm laughing at you. I hope my man would appreciate that, my man Embry here. Aha. Idiots. All right. So moving on. I can't help it. I'm usually the smartest guy in the room. I said that to somebody who said that what makes me think I'm so right and everybody else going another direction. I said, I'm usually the smartest guy in the room. So if they all go in the other direction, I'm going that way. They need to think about which direction I'm going, because I'm probably the right guy. I'm usually, when I open my mouth, I'm usually not the wrong guy. I'm usually the one that sees it right. And so far, I get to pat my own back. Hold on. Let me do that. All right. Strut and tie, tension force. T1, T2. So that's balanced. Whoa. They changed the degrees. And wait a minute. So I'm just trying to see the intent of this real quick. And I don't remember seeing this anywhere. So it's okay, I'm starting to get it. So it pulls off to the right. And this is where the deck failure was, right? So it pulls off to the right. Here and here. So all things being equilibrium, that means I got to think about this. Don't hold me to this, but that means it's also pulling up with the same amount of force that it's pushing down on, which is putting a tension, a compression upwards here, and well, where would they meet? At the directional change? This is very interesting, guys. This is very interesting. Then I got to think about, this is going to get another video from me, because then I got to think about how it relates to what we actually see in the damage, where we actually see that things are not broken, but we do know we have breaks around here. This is interesting, and they didn't do it balanced in this drawing, but is this a plan? Strut and tie design strength check. This might be a repair. I don't know. I don't know. I hope it's a repair. I hope it wasn't in there. I hope it wasn't in there, because then that would be weird. It is not balanced. All right. And I didn't find any of the plans. Construction strength checks. The purpose. So there's your, equilibrium. Since the span was actually weighed conservatively, so he's saying you could take half the weight, but the structure is not uniform. So I don't know how he can even think of that. It's his own structure, and it's not uniform with the truss members design. The canopy and the decking appear to be uniform, but the truss members are not uniform. So I don't know how he can say that he can just use it half. Strut and ties. Well, here's my answer. Area of a steel tie equals 8 times 1.5. Construction strength checks. Strut and tie. Oh, this is the repair I think we're looking at here. It's a weird repair. He's got it anchored. If it's a repair, he's got the loads to try to say the reinforcement coming on the bottom of your feet, if you will. Instead of down here, jumping all the way down to the pier. Somehow he's using it here, or was it on the pier? I can't tell. I can't read it. I can't blow it up. Doesn't see a thing. Don't see a thing. Here's your equilibrium again. Has to be equal to the tension in the rebar, where the compression in the concrete has to be equal to the tension in the rebar, and the moment created up by the distance between T and C. Nothing for us to get out of that. This looks like it's part of his repair plan, but this never was implemented. Okay, nodal shear transfer of vertical loads. All right, the diaphragm cross-section area is approximately 2 foot by 4 foot, equals 8 square feet. The shear from the two shim on one side is approximately 476,000 kips. The shear from the two shim, whatever that means, on one side is approximately 476 kips. So the shear on the other with two shims would be the same, 476 kips again, right? So thus the average shear strength from the vertical load is approximately 60,000 ks per foot, kips per square foot, which is within normal range, 8.5 KSI concrete. But we're at 6,000 concrete. This is confusing. We're at 6,000 concrete. They're talking about 8,500 concrete. Well, that's confusing. Why didn't anyone call them out on that? Saying, where are you getting the 8,500 from? I'm trying to think if the pier is 8,500. I think the pier is also 6,000. I know the bridge is all 6,000, right? It's all one. Nodal shear transfer of vertical loads. For the shear friction transfer between the diaphragm and the nodal region here, conservatively, the transverse post-tension is not considered, and only the mild steel is evaluated. Also, the cohesion term of elevated shear friction. This just not evaluated, just removed. Let's see. Nodal shear transfer of vertical loads. Number 83333. I have to go over all this to figure out where these transcribe to, if you will, for where they match up, right? Sliding on. Nodal shear transfer of vertical loads again. Factor shear demand, reduced capacity, easily okay. I love that. You know, I give myself a thumbs up. Well, that's the same thing as giving yourself a thumbs up. That's awesome. All right. Total nodal shear stability. All right, here we go. 950 kips, pushing up, pushing down. Same thing, plus or minus whatever he's made up. I guess that's the plus or minus whatever they messed up, whatever the real weight is. The total node must remain attached to the diaphragm deck in order for the longitudinal tendons to capture the longitudinal force component of the strut. And this would be his strut system, the entire thing. Can't read a damn word that says there. So I disagree. It would be, if there's no cracks in that diaphragm, it's transferring the load may be concentrated onto each contact point, but if it's not reflecting or showing itself with cracks everywhere at those points or between those points, if it's not showing those cracks in those points in this diaphragm, then you're transferring the load without any harm, no foul. Yes, you must grout it as per his plans, but he seems like on this one, he might be trying to throw the grouting. The grouting's not done under the bus. It's not me. The grouting's not done. The grouting's not done. This just seems like that's the true intent of this statement there, that is trying to punt again. Total nodal shear stability. Now we're talking about the rebar placement. Rebar crossing assumed shear plane. I don't know where these are, so I'm going to keep on rolling. 2 legs. No friggin' idea where that is. I mean, I couldn't extrapolate that properly. Total nodal shear stability, transverse post-tension confinement. There's this. There are 65 4 by 0.6 diameter tendons in the 175-foot span. The total transverse tendon force is approximately, oh, this is so awesome. He added this up. I was going to play with this, and now this is disclosed. So then you go to this, you figure out the weight, and you figure out whether that load is defeated. The weight of the structure is defeated by these kips of the transverse tendons. Whoa, that's transverse. I meant longitudinal tendons. This is really nothing to me. It's because it didn't break in this way. So the assumed nodal has a length of approximately 4.75 feet. Thus, the tendons provide 54.8 kips a foot. Yeah, this, I don't see that being the cause of the failure. So, although I did talk about it folding up a little bit. Is to neglect the cohesion portion when practical. Thus, without C, whatever, total nodes. Oh, the upper, he says, were checked and also found to be within limits. So this is his presentation. It's an interesting conclusion based on conservative. Yeah, I thought that was the end of it. Based on conservative calculations, it is concluded that the design meets LRFD strength requirements for this temporary condition, and therefore is no safety concern relative to observed cracks and minor spalls. Wow. Okay, this is the nodal area saying adjacent to, and we're talking about these cracks. Well, apparently we're talking about the cracks over here is adjacent part. The evaluation include the 4 shim locations placed at the end of the span movement. So here's the transverse cables going across. 1, 2, 3. He looks at and no longitudinal and the shims he's highlighting, along with some reinforcement points. And moving on. Dimensional element. Several different loads and load combinations were considered to understand. Several different loads and load combinations were considered to understand both total state of stress and efforts of some individual load components. Total self-weight in all post-tension transverse longitudinal post-tension bars, all PT. Stress changes from transferring the weight of the span onto the shims. Stress changes from stressing or slackening the post-tension bars in number 11. So that's their version of it. Number 11 is very important for him to mention. Number 2 is not even mentioned here. All right. Oh, there's a diagram. Cool. I mean, his little, he got that, whatever program he's using, showing the stresses. We need more of this. Stress changes from placing onto shims. Here are the 4 shims. When the span was placed onto the shims, question, are the stresses on the diaphragm essentially equal on the north and south face, or is it one face more highly stressed? This is very interesting. North to south face, and I'm guessing it's from the north end of the bridge and south end of the bridge. So he's asking the question. And the next statement is, the results indicate that the stress change on the north and south faces is relatively uniform when the load is transferred to the shims. Yeah, that's balanced. That's what I said, except for the weight of the couple diagonals being longer. However it divides down the middle is what I said. Total stress when on the shims. And this is his diagram of it. His software. And I'm looking for, again, equilibrium. You look for equilibrium here. This looks like this is the software they ran their programming that they entered their data in, and this software came back. Looks pretty damn balanced, doesn't it? I mean, this is balanced as can be. So this tells me that, hell, leave it alone. Just grout it and call it a day. It's kind of odd, though, that these stresses aren't equal out here. That these this red, if we will, is not also red down out here. It's lighter on the outside here. The canopy, the overhang, it all comes down. Oh, we don't see the rest of it. It's got an overhang here. The overhang, I would think, would put more force down on the ends. The cantilever. Let's moving on. Diagonal crack pattern. If it wasn't shimmed here, and it was shimmed here, this would put this as a cantilever at that point. So if this one was in contact, and this one was not, and I know they shimmed along on the deck, on the pier cap, or pier, top of that pier, pylon they call it, I think, that would make this an overhang and put more stress up here. So this is theoretical. It's not actual. He's not actually showing the literal load contact points. He's got this as perfect. There's the problem with his drawing. He has these perfect in contact with the underside of this diaphragm. Where we see in the video, just saw that they're talking about they need to make it perfect, the grouting. So this is just, academically, just BS. Because it's not showing the real contact points and how its loads will be reflecting. So that's basically just fantasy above. All right, diagonal crack pattern. Both the hand calculations and the 3D volume element analysis concur that some cracks of the nature photographed are possible. All right, so 3D volume element analysis. Well, that's not true again, because you just talked about these need to be grouted, shimmed properly, etc. And yet now you show a uniform. Your analysis shows that no harm, no foul. This under the load point looks the same as under the non-load point with when it comes down to right about where it's transferring the load. This pattern looks equal, balanced. So there we go. Why the cracks did not develop in the casting area is likely related to having a substantial portion of the load carried into central. There we go. I told you he's trying to blame it on the Barnhart. So there we go. So you're going to blame it on Barnhart. Problem is the FDOT said that you must, you shall, they did not say shall, they did not say must. That the manual says that you should consult with the transporting company about the contact points. And how can he say this? This would be him attacking himself, because in his drawings, he talks about where the SMPTs go. And I know initially we all got trolled on that because they were showing us 2016 plans. But here in the 2017 stamp plans, Denny PATE's plans, the SMPT are placed, and there's a drawing coming up, are placed exactly pretty much where he says they should be placed. And give me a moment, it's going to be bottom left also. Don't ask me why I remember all this crap. It's going to be to the left of the page, I mean. La 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 la. Bear with me. Bear with me. I'm gonna look at your comments in just a moment too. Also, rather. La 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 la. SMPTs. I'm just looking for the little transporter. Or did I just pass it? It's gonna be on the left side though. So there are the shims. That's nice. Concrete, 1 3/4 inch minimum thickness. Concrete bearing seat, rough and top of the. Well, it's actually looks like nylon that's been changed. Bearing replacement, partial plan bearing replacement. Concrete bearing seat again. They changed it to something else. And there's your shim plate. Shim plates were supposed to be installed. I remember now. Shim plates. Okay, that's what they were crying on about. And there's your meeting your standards. There's your LRFD also. Your standards of what you're going to be following. And there it is, during bearing replacement, unbolt the bottom stay pipe connected prior to the jacking of the span, blah, 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 bearing replacement notes. This is if you had to redo it. And moving on. SMPT, oh, there we go, right there. Transporters, 2017 stamp, right here. Slide over. There they are, placed where Denny PATE said place them. These are his drawings, these are his stamps. And now he comes out trying to crying foul when they're placed. And when they're placed, where are you? When they're placed where they're placed. Why the cracks are not developed in the casting area is likely related to having a substantial portion of the load carried in the central area. Well, it was your drawings, buddy. It was your following. Barnhart and I did their stuff on that. They said that we did not, we weren't consulted ahead of time. They were not. I couldn't find anywhere where they were paid ahead of time or anything else. They were not consulted ahead of time. Having the smaller crack width on the permanent exposed face. Having the smaller crack width on the permanently exposed face is preferable when compared to the other to be embedded diaphragm face. Okay, so no idea how he's trading off what's better. Oh, awesome. Look, this is the over there in the impound. It is unclear how a change in distribution of contact pressure on the bottom surface from being supported like this for several weeks. All right. It is unclear how a change in distribution of contact pressure on the bottom surface from being supported. So Denny PATE, the engineer, bridge builder, is unclear on how things happened here, how things changed. He's unclear. It's unclear to him. Well, you had a cantilever, and I talked to you guys about cantilevers when you're reinforcing it. This reinforcement is pretty much down the center of this structure. This 1 foot thick pad, I think it is roughly. And a cantilever, if you're going to support it as they did here, the reinforcement will be at the top of the concrete, and that resists the stresses of it wanting to bend down, not at the bottom part. But you neutrally located in the middle is like a tray. It's neutrally located. It's not really hooking you up, except for, say you post tension these, right? It's working great, as they said. Then you put the load here. Then you got this cantilever that this bridge, these post tensioning never experienced before. Now they elongate somewhat. I'm waiting for them to get to that part, that these were elongated. Simple as that. The post tensioning might have worked, but they elongated. They didn't go back and rebite at it again. All of them at one time. I mean, all of them. All 12 of them post-tensioned at one time once they have it over there. That's what I would have recommend on such a crazy adventure. You're going to be chasing your tail trying to do torque on one if you think of it as torque. Torquing one, then torque the other one. Then check the torque specs on the last one. The clamp force is different on that one. Now go back to the other one. Your clamp forces are going to be all over the place. You're going to have one doing more work than the other. And then you're no longer going to be elastic. You're going to get you're going to be past your range of elasticity in the damn cables, perhaps. Oh, whatever. to being supported on bottom. So he's just punting everywhere. So we're back to the shims again. Shim plate typical. Well, let's move on. Could possibly create these top spalls. Okay, we got new images. All right, we saw this image from the idiots and NTSB, but not this far up. They zoomed in on us. And maybe I can find this from the FDOT now, but this is further out. And okay, so this is number 12 going, well, I think, no, we're looking down, but what the hell? Now we're starting this crap again where I can't get my orientation. I see the outside. Okay, I see these two, but what's this? It's almost like I can see through the bridge, but that doesn't make sense. Through the base. Because there's the pylon out here. This is the pylon it's sitting on. There's that burn marks I was talking about. There's the cracks now. But there were cracks here. So this looks like a different crack, doesn't it? Okay, could possibly create these top spalls. It's just by itself. He just did a presentation, one screenshot, could possibly create these top spalls. So he's not sure. So what are you saying is creating these top spalls? Going back to this. So he clicks through the presentation. So we run across this first. He goes, click on the presentation, and I'm talking to you. It is unclear how a change in distribution of contact pressure on the bottom surface from being supported like this for several weeks, and then click the next screen, next slide, I'm guessing, to being supported on the bottom of the 4 shims, click next screen, to a question, could possibly create these top spalls. So it's unclear how those could have created this. Well, don't try to tie it in. Maybe you got failure another way. So he did the post hoc thing. He decided that that was related to this crack, but it's unclear how. So he had data. He made a conclusive file, and with the question mark on his conclusive file, but he can't make the data match his conclusive file. Moving on. The total plotted as principal tension stresses from the 3D model. Well, again, I'm looking for equilibrium first thing, right? And it's a model. Now, you know, guys, I hate models. I like common sense, old school. I'm much older than you guys think I am. This plot has diagonal post-tension bars and members 11 stressing. Okay, so he's saying that number 11 is, this plot has diagonal post-tension bars de-stressed. Okay, so de-stressed, and it's showing that 11 is acting like the deck. Status quo, nothing. And that's that 950 kips coming down here. The hell of a lot of weight he's got coming down that thing. How the hell did he get that 950 kips down there? It's like half the damn bridge coming down here. How did he get that? The canopy's not that big. So some of that load must be working its way back into the canopy and down number 12. But didn't even look impressive. Moving on. And the change principal stresses solely from distressing the post-tension bars. And okay, the change principal stresses solely from de-stressing the post-tension bars in member number 11. And so this is 11, I'm guessing. Trying to get my orientation. This is 11. Yeah, that's a tough one, isn't it? The way you configure this. But it looks diagonal-ish and, box shape and the cut. But he said this is from their design. They don't have their 8-inch concrete in there. Nothing showing it. Nothing is showing having issues. But yet we know there's cracks in this thing. So this whole computer model dropped the ball. It's not showing cracks. The analysis neither total stress. The analysis neither total stress nor post-tension bar only stresses shows any spike in tensile stresses at the corner of the deck. So it does not show any spike in tension right here of number 11 and 12 at the deck. He's talking about tension, what I've always talked about. I said it's in tension. He says it doesn't show it, but yet clearly it's identified itself. So conclusion and recommendations. The diagonal type cracks and excess of FDOT criteria, okay, meaning FDOT won't allow those excessive cracks, should be sealed with approved methods and materials. Epoxy injection. I think I joked around about epoxy injection with this, you guys. Can't believe it. That I said, of course you wouldn't do epoxy with that. Apparently, that was where they were going with that. And where you beyond injection, that'd be like epoxy pouring. And then epoxy is going to be in tension. And what? Bond to the post-tension bar. And then, or possibly bond to the post-tension bar. And then you're going to de-stress it, but the epoxy is going to act different in expansion and contraction than the concrete. So this is just a weird thing here. Because this epoxy is going to be friggin' 60,000 PSI. So now you defeated the purpose of FDOT's rule saying your grout and your concrete will all be of one consistent PSI. So by doing epoxy, you now created a conflict. You created a shim that will start doing cracking. That's what I project. The spalling areas have not been replicated by the engineering analysis. Yeah, I told you guys it doesn't show. All right, so I'm reading this good. I'm doing good so far because it doesn't show the cracks. And here it is, he says it. Have not been replicated by the engineering analysis. However, the spalling areas are minor, and it is recommended that they be prepared using normal procedures and poured back along with the upcoming pylon diaphragm. Pour. Different from and prior to the backspan on false works pour. So get to working on it, the repair Saturday. That's 44. They hit 44 on that. All right, let me see your comments and then let's see what we got here. So Doss, why did FDOT decide to release the presentation today? Well, they're obviously now saying that we don't care about, well, obviously what's the name going to come forward now? That NTSB is done and FDOT is like, hey, if you're done, you can't, no harm, no foul. We can't get any more data from you. We can't get any more protection from you. So we're releasing ours. Because remember this, that when you participate with NTSB's program, if you don't like what they say, you can actually dispute with them their findings and maybe get your point across where they'll adjust their findings. So either NTSB is going to mimic the FDOT report, or this is FDOT fighting what they already perceive as NTSB's release. Remember, NTSB also, if they kick FDOT out, NTSB will not be able to see the findings before they release. But if they're still part of NTSB's program of the secrecy agreement, then they will, not may, they will receive a copy before the release and have that opportunity. So my thinking is that the NTSB is giving this permission to FDOT, or FDOT has already did a counter to NTSB's conclusion, and now they're trying to get their own stuff out front first. But let's read on. I fix home and sporting stuff with epoxy. It is hit or miss. How is it appropriate for these massive cracks? FDOT, see you, cover your ass before the, oh yeah. Well, I'm not saying I don't think NTSB is going to come down on, it's going to be anything dramatic. It'd be nice. But here we go. So that was May 6th. Now we have Exhibit A, scope of service. Any documents with the word cracks. All right, baby. Reconstruction conference minutes. December 12th. 105. Description project. The project consists of, this is when they were calling the meeting, is maybe. Scope, right? Important, estimate, okay. Sidewalk drainage. Already seen this. I got this disclosure already. Yeah, it's from FIU. I got that from FIU already. Um, and then anything with the word cracks in it, we saw this already. They were somehow monitoring it. I think this was that one. Exhibit A, 1 of 1. This is that FDOT's thing. If I remember, I did this in a video, and the acronym was was it wasn't the federal government's acronym. It was the that one. Look, I forget which one, but that's all. It's just an acronym for that. Oh, great! Can't open that one. And this was them, I think, showing they were monitoring the internet for anything with the word cracks in it. When you saw that, let me go backwards. It says, so that turns out it was FDOT monitoring. It says any documents with the words crack or cracking. Well, it says documents, but FIU was monitoring too, as you guys remember that. And there's the pylon meeting. It was actually, there's your certification right there, LAP. So the this is where the true, it says 175, the span is really 12 feet. Everybody says it moved 11 feet. All these experts, and I did a video on this saying, hey, it's 12 feet. It's not 11. See? 12 feet. Everybody's talking, it's moved 11 feet wider. It's 12. You're triggering me. Let me get off of that. So there it is there. I think I'm going to trash this with you guys. I'll copy that, and I'm going to dump this over here. And you guys now have access to that. Your lovely access. Enjoy. And what else we got? So that's it. Any questions before I hit the rack? I got to go take a shower and a bath. I love baths. Shower and a bath. Any questions before I roll out on you? I think you have this now because you have that. That link will get you this. I'll give you this, I guess, the drawings. And so I'll edit that. And do that. And I'm going to scream in your ear. I'm coming up. I'm coming up. Okay. So let's see. That's that one. You saw the shims you can find in there. What else I have over here? This one I can almost give to you. Not yet. You guys got to track that down. You can. I think you can now. I apologize for that. FDOT. Okay. This was May 6th. This is their standard one-page press release, but there's more behind it, obviously. After the Florida National University bridge collapse on March 15, 2018, the National Transportation Safety Board investigated was initiated immediately. Blah, blah, at that time, the NTSB enforced a public records restriction on the Florida Department of Transportation. The department has been working with the NTSB to proactively get the restriction lifted. We support full transparency by providing all documents related to the March 2018 tragedy that impacted the South Florida community and our entire state, explains FDOT Secretary, blah. Lives were lost, blah, blah, blah. While we have worked with the NTSB allowing the release of public records that have been requested by the media relating to the FIU bridge, the department will wait to comment further until the NTSB release the final report. Okay. So there's your answer, Doss, I think it was. And the weeks to come, the many court cases and other variation investigated will be going, blah, blah. Documents. And let's click here click there. And that puts us here. So go back here. No, no, over here. See you guys over here. And what else we got? Interesting. Someone photographed the presentation. Must have had a reason. Well, it was FDOT was photographing it, and they said some of their images weren't captured. They didn't capture all of them. And what's this 6 mean? You gotta think 6, no fixing. Right. All right, so you guys don't mind, I'm gonna hit the rack. I don't know how long I've been going at it. Oh gosh, too long. All right, so good night. Enjoy yourselves. Thanks for watching. And I'm trying to figure out how to stop this. So this says stop there, but it always gets me in trouble when I do that. Let's try it. No, it didn't stop. Didn't stop. You stop it here. I need better lighting. Oh. Oh, wait a minute. Dawes said something. Still on. Yeah, Dawes. Thanks, Tom. Have a nice bath. Thanks, Tom. Hey, Tom, I still got that. Do that video for you. With the concrete grinder with the three heads on it. Yeah, I know. Now I went to this, and there's my light. Let's see if I can do the Bela Lugosi thing, right? Since you guys got a good sense of humor, isn't it like that? Since you guys are older too. All right, take care. Good night. Oh, wait a minute. Somebody else commented. Tom, okay, cool. Miss Nicole, thanks for sharing all the docs. Hey, you're welcome, Miss Nicole. Now I'm sorry for playing around with my camera now. I thought it was just the regular crazies in here. We got a new crazy person. Your entire screen. I got to do this to get out. I go back to the screen. And then once I'm at the screen, I can do stop broadcast. Google is a special animal. Hope you enjoyed my little humor at the end. Before I go, anything else? Good night, good night. Miss Nicole, Dawes, Tom. Yep. And stopping.